Okay, so now we're in 5.2, where we're going to be talking more about instances and static methods. So let's get into it. Five point two instant methods. As we learned in the last chapter, instance methods define the behavior that are unique or specialized to each class. Every object created from a class will carry a copy of these methods. Instant methods depend on the data stored in an individual object. If two objects call the same method, the results will vary when the objects contain different data. Let's add a couple more instant methods to our student class. What are the behaviors that our student class should have? To start, it makes sense that when a student takes a class, what are the behaviors that our student class should have? To start, it makes sense that when a student takes a class and earns a grade, their data should be updated accordingly. Additionally, it would be nice to easily identify the grade level of a student, freshman, sophomore, junior, or senior. The framework for these new methods is shown in the student class below, but each method is missing some code. Filling in that code is left for you to do in the chapter exercise. Okay, so in our chapter exercise, you're going to fill in the code down here where we say update the appropriate fields and number of credits. But let's look at it for a second here. So we have the student class here, which I have it over here as well. And we have these objects, which are called the fields or variables. And we have one that's private static int new student ID. What does that mean? That means that we can use that next student ID in each part of the constructors. It doesn't change. So that's why we're making it static. It can be used across the board. And we're using the next student ID. And when I say, let me take that back, when I say change, I mean it can be used over and over again. We know that it's going to start at 0 and we can increment and add to it every time we add a new student, which we do have an example of a student constructor with just the name parameter, which you have right here, which is on line 21. And then we have private string. So when I see private, you should be thinking encapsulation. You should be thinking that, okay, this is going to have some getters and setters. And now as I go through it, notice that they're private. And when they're private, and when I use those getters and setters, I can use those across when I create my new class instances. But if you notice here, these private variables or fields or objects, they're just declared. They're not initialized. They have no value yet. I'm going to add the values later. And as you go through, you look at the first constructor. How do I know it's a constructor? Because the constructor matches the name of the class. And so I have a string name, and I have the int student ID, int number of credits, and double GPA. So I have all the objects inside my parameters for this particular constructor. And then I'm using the this.name, and I'm assigning the name. This.name is referring to line 4. This.student ID is referring to line 5. These are the objects that this is connecting to. Same for this.number of credits and this.GPA. Now, when I go to the next constructor on line 17, you notice that I have just the name and the student ID. These are normally the students that have already been created. They may be coming from a different school. So I want the student name and student ID. And so that 0 and 0, what does it represent? It's going to represent the number of credits and number of and the GPA that I can add later. And then I have another constructor, which is the string name, where I'm just going to, if this is a new student, then I'm going to give them the next available next student ID. Now notice here, I have me another string called student info, which is a method. How do I know it's a method? Because student info has parentheses, and that's where I'm going to pass it in a statement. Same way, now I have a public void add grade, where I am initializing, of course, credit and double grade. Okay, so that's something new that I'm introducing to this particular method, which is because I'm declaring an course credit and I'm declaring a double grade. And that's where you're going to work, and you're going to add in your exercise in these two positions here. And then we're omitting the getters and setters, which we do have getters and setters because none of these private static objects have final. So remember that. So because they don't have final, I can have a getter and setter. If one of these had a final, I wouldn't have a setter. Okay. Tip. When creating your classes, think about the behaviors that you want to make available, as well as the access level of those methods. You know, you think like the compiler, think like a developer. You already should know what the output is going to be before you even create the file. You have to understand how you want to use those fields. Are you going to make them private, or are you going to make them public? So think about it. It takes some thought, and it takes practice to really get good at this. Now here we got 5.2.3, static methods. We've already used static methods quite a bit in this course, all the way back to our first Java method, public static void main. Now let's examine them in the context of what we recently learned about classes. Just like static fields, static methods belong to the class as a whole and not to any of the specific instances of the class. Thus, they are sometimes also called class methods. A static method is essentially the opposite of an instance method. Remember now, we got two words here, a static method and what we call the instant method. Since the two cases are mutually exclusive, instance methods rely on each object-specific data, while static methods must not rely on data from a specific object. Notice the difference here. When I said not, when I think about a static method, I know it must not rely on the data from a specific object. We call a static method by preceding it with the class name and using dot notation. Here's an example that we looked at previously. So we have the hello world or the hello methods, and we have public static void, meaning that we can run this, and we have a string message, and we're saying message.getMessage. And so this is what we call a static method, right? Because we're using the dot notation. So remember that it's preceded with a dot notation. Now, in the message Java here, we have message. We're calling message on line 5 in the hello method. And so in here, this is a static string get message. See, message, get message. So message is the class, get message is the object or is the method. So message is the class, get message is the method. And I have access to whatever is inside of this particular method, which there's a check here or a conditional. If I didn't I say get message and I'm passing in FR? So if it's FR, it's going to return bonjour, meaning FR stands for French. Now, the call occurs in line 4, message.getMessage. Remember again that this is a static method. Why? Because we put the word static on the method inside of message. We call the static getMessage without needing an instance of the message class. Instead, we use the name of the class itself. So what does that mean? I don't need to use new, the new keyword. Okay. Warning. It is technically allowed to call a static method using an instance of a class. I can use the new keyword, but it's telling me I don't have to. My object.sum static method. However, best practice recommends using the class name instead. Class name dot sum static method. This makes sense. Warning. It is technically allowed to call a static method using an instance of a class. My object.sum static method. However, best practice recommends using the class name instead class name.sum static method like we did here. We're using what? Message, which is the class name. And not just message, lowercase, right? And so here, this makes it clear to other coders that you are calling a static method. This is why I say best practices. We want to use a standard. We have a standard. That what makes us more efficient when we're coding, because we understand the standard that everyone is using. So it takes away all the confusion and guesswork. 5.2.4 Accessing static versus instance fields. One common error new Java coders encounter reads something like non-static variables cannot be referenced from a static context. This occurs when a static method tries to call on instance variables. Why can't we do this? Static methods can be called from anywhere, depending on their access modifier, and they do not require us to create an object for a particular class. However, these methods must be independent of any value unique to a particular object. For example, if we have a circle class, then we can define and call a static area method without recreating a new object, like such circle.area_radius. Since the area of a circle is just pi times radius, we can pass in the argument when we call the method. The method does not depend on any value stored within a specific circle object. Now, let's assume we define a car class with an instant variable for color. The value of this field will not be the same for every car object we create. Thus, trying to call a static method like car.printColor results in an error, since there is no single value for a color that applies to every object. Trying to access it from outside the class does not work. To print the color of a car object, we must call the method on that specific object, mycar.printColor. Instance fields can only be called by instance methods. Okay, so here, what we're trying to say here, static, remember, static can be used anywhere because it's pretty much the same. So like, for instance, the color of a car is general, meaning it could be any color. So therefore it can't be static, because if I try to call the method that way, it's going to give me an error, because what are you asking the color of the car to be? I need an instant variable for that. I need to do an instant method for that. So that method is called on the color of which is we call the object, and then the color that we want to make it. So if I want to make it red, I can when it's on the instance. But if I do a static, it needs a default basically. So for instance, if the color of a car can be anything, but what is it on the car that is the same for every car? Well, every car has a windshield. Now, when we start getting into particular windshields, that's a different story. But really, every car has a windshield. So I can make a windshield static, if that makes sense. Hopefully that makes sense. All right. So let's get into the notes. While static methods cannot access instant variables, an instant method can access a static variable. Now, we're asking you the question, why? We want you to go back and figure out why that is possible. We have your references here. Check your understanding. Now, that's the end of 5.2. And we're going to get ready to go into the next section. But remember, the more you practice, the more you improve. See you in the next video.